Hello, everybody. Can you hear me? Yes. Cool. My name is Maria Neumayer. I'm an Android developer at Deliveroo. And today I want to talk about being a lazy developer. Now, lazy is often seen as kind of like a really negative attribute, but it can also save you from making mistakes because you're trying to avoid to do the work. So you're going to research a bit more and spend a bit more time on actually figuring out what exactly you want to do before jumping in and just getting started. And a few months ago, I was playing around with architecture components and data binding and a bunch of other libraries. And I started to realize that I didn't have a lot of code left to write. All of the boilerplate code was done for me, and all I had left to write was my actual app logic. So that's great. When I got started on Android, that wasn't the case. Like, there were no libraries, there was no support library, no play services, and I had to write everything myself. So being a lazy developer was really hard back then. But as I started to use all of those different dependencies, I started to think, like, would I actually use them in a real project? And what is actually a good dependency? And why would I actually use one over another? So this is why I'm doing this talk today. So if you think of being a lazy developer, what is kind of seen as your measure of success? Well, you might think it's you want to write as least code as possible. But I see it more as writing code most efficiently, because sometimes you might have to write a bit more code, because maybe you can reuse it somewhere else, or maybe it's easier to test, and that will save you time somewhere else, because you don't have to manually test. Or later down the road, you don't have to write a similar code again that does kind of the same thing. So you don't want to write code, or you want to avoid it. So what do? Well, you can let others write it. There's a ton of different options out there. I'm not saying, tell your coworker to write the code for you, but you can use existing code, use libraries, and there's loads of dependencies for Android out there. But when should you actually use a dependency? And how do you decide which one you want to choose? And how do you then actually go about to integrating that dependency? And these are the questions I want to answer today. So let's start with the when. When should you use a dependency? Well, the short answer is when it's the best decision to do so. And the long answer is, it depends. There's no golden rule. Like, you can't say this is exactly when you should use one and this is when you shouldn't. But there's a few different requirements and a few things you can think about. But let's start with the why first. Why would you even use a dependency? Well, a dependency can save you from writing a huge amount of code, or help you having a cleaner architecture, or just simply help you make your app more beautiful. So that's great. But you might want to say, like, I'm in control. Like, I want to be in control. If I write code myself, I know what it does, and I can modify it, and do whatever I want with it, whenever I want. And that is true, but it's not always as easy as it seems. With the library, somebody generally thought about a problem. A lot. There's a lot of side effects to consider, performance, maybe edge cases, and with the library, somebody generally thought about that for a long period of time. And often, it's not just one person, it's a whole team working on it. How often did you write some code, create a pull request, and then somebody's like, hey, did you think about this? And you didn't. And you have to go back and change your code. Or maybe you released your app, and then it crashes on some obscure device that you didn't even know existed. With a library, that's generally already been done before, that's already tested, that's already been fixed. So you can depend on somebody else's knowledge and focus on something else. A library is usually for a very specific use case, maybe for image loading, or like analytics, or maybe it just helps you remove some boilerplate code. And that means you can save some time, and actually will help you to build a better product, because you can spend that time that you don't have to worry about that specific use case, and actually work maybe on a new feature, or a great animation that you wanted to add, or maybe you can finally refactor the code that you wanted to refactor for ages. But dependencies also evolve. Like, as you're working on your app, somebody else will start working on the dependency, and you get a lot of new functionality or bug fixes, and you pretty much get that for free. You don't have to do much for yourself. And is there anything missing? Well, you can always provide feature requests, or maybe provide an issue if there's a bug. And Maybe you can even write it yourself and create a pull request, and then actually help the community by making the library even better. So that's one of the great things about open source projects. You can shape a product together. Like, we as a community can shape a library and build a better product for everybody. So as you start using a lot of dependencies, you might want to wonder, like, will this actually bloat my app? Won't it make it huge? Because there's a ton of dependencies there that I'm using. And for some dependencies, that is true. Support library or play services, those are huge. They do a ton of things and have a huge method count and an app size. Right now, I think if you create an Android project from Android Studio, it includes those, and you already hit the 65,000 method count. But with ProGuard, that is no longer a big issue, because you can actually strip anything out that you're not using. And that's great. So you're only using what you actually need. And also, the 65,000 method limit is no longer a big issue, because there's multi-dex. But you still need to worry about dependency size sometimes. And that is mainly when there's native code involved, because those can generally be really big. You can do a few things like creating a split APK, but in general, those are relatively big, so watch out for those. Sometimes, though, you will need control. Sometimes you need to make sure that the code you write does exactly what you want it to do and is as efficient as possible. And in that case, it might make sense to write it yourself and not rely on another dependency to write it for you. OK, so when should you use a dependency? When it makes sense. Is the problem relatively generic? Will it actually save you time in the long run? And can it make your app better? If you can answer those questions with yes, then yeah, sure, go ahead and use a dependency. It's great. And now there's a bunch of different options. So how do you even decide which ones to pick? What's actually a good dependency and what is bad? And will a dependency actually do what you need? How do you find out? Well, I asked on Twitter, like, how do people decide to use a dependency? And Paco replied, like, did I write it? And sometimes that is a good option. Sometimes there won't be anything out there for you to use. But that doesn't mean you can't write it as a dependency. You can write it as a library and then open source it, and then help everybody else to build a better product. And maybe you can also get feedback from others and help. And you can all shape that product together. So that's great. But we're just getting started here. So if you can't write a dependency or you don't want to, like, what do you do? Well, first thing, you can use the community. You're probably not the only one with a problem. So there's probably going to be a bunch of blog posts, maybe talks, or different comparisons out there that you can rely on. And that is really useful, because sometimes a dependency might look great on paper. It's like, yeah, that looks cool. That's what I want. But as you actually start using it, maybe it doesn't actually quite work. Maybe there's bugs. Maybe it's actually a lot harder to use. So having somebody who has that real-life experience and being able to rely on that person is really, really useful. And sometimes you don't have to go far for that. Maybe someone on your team was using it. And that's the best possible outcome you can have. Because if somebody on your team knows the library, then they know your needs exactly, and they know your code base, so they will know if it actually will work for you. Because every app is different, and what works for one might not work for another. OK, so now you found a few different options. Like, how do you actually then know you can use it? Well, the first is check the license, and that is very important. Disclaimer, I'm not a lawyer, and I don't know a lot about licensing. Somebody could probably do a whole talk about that. But there's a few things you can watch out for. And the first and probably most important one is there a license? Because if there's no license, it is copyrighted, and you cannot use it. You might think you can, but you actually can't. Right, so there's a license. How do you know you can actually use it? Well, most dependencies will be MIT and Apache 2, and those are relatively free to use. You can modify the code and integrate it. You can do pretty much whatever you want. You just have to add a notice. So GitHub has this great screen for licenses. So you just need to open the license file of a dependency, and it'll tell you what the license is, what its permissions are, its limitations, and what the conditions of use are. Now, if the library is hosted somewhere else, or maybe it's even closed source, that will not be as easy. But if it is on GitHub, that is great. If you're unsure about the license, double check with a lawyer, because they will know exactly what you have to do and if you can use it. Don't assume it will be all right. So now you know you can use it. What do you do next? Well, the first place to probably check is the README, because that generally should have a bunch of information, like what does this library actually do, and how can you use it? Maybe that information will be on a website or on some other documentation, but you need to make sure that there is some information out there. Because like if somebody didn't spend an effort on actually writing that README, how do you know they spent the effort on writing code well? And there's a few other things I'm going to talk about now, and I'm going to make the assumption that you're going to use open source libraries. There's also going to be a few considerations when you use closed source library projects, but those are generally not the dependencies you choose to use. Those are the ones you have to use. It's like analytics and things like that, where somebody on your product team tells you, we need to integrate this library, but you don't really have much of a choice. So if it's open source, what do you check? Well, pull request is a great place to start. And what you want to check there is, are they actually being accepted? Is anybody actually looking at them and responding to them? And what is their attitude towards merging? Like, having rejected pull requests isn't necessarily a bad sign, because a library should do one thing, and it should do it well. So if a pull request actually has bad code in it, or maybe it does actually something slightly different, you don't want to add that to your library. So if everything gets accepted, that's probably a bad sign, because that might mean that the quality is actually not as good. Because code reviews are really, really important for libraries, because if something breaks in the library, that can break a bunch of apps, and you don't want that. So here's a pull request screen of Dagger, and that's really good. So you can see there's a bunch of open pull requests, but that's okay. But all of them, or most of them, have some comments. They all have a CI check and a label. So somebody's actually looking at those. They're not just being ignored. So that's great. A very similar approach goes for issues. Again, are they actually being addressed? How long does it take for them to get fixed? And again, them not getting fixed might not necessarily be a bad sign. It might just be a random feature request or like a super low priority bug, and that's okay. But you also need to remember, most of the times there will be other priorities. Most libraries are created as a side project, either at work or maybe even in your spare time. So you don't have to, you can't expect a response like right away. If there is, then it's great. But sometimes you might have to wait a while until somebody can actually look into your issue. But you can help the developer by making sure you provide as much information in your issue. And if you create a pull request, make sure you follow the coding convention of that library. And also check what that actually does, and if it's a good idea to add your feature. Another thing you want to check is past releases. Past releases can help you figure out if the dependency is actually being updated regularly, and if it's actually still active. Also, it can tell you if the API is stable, because if with every update of the library, you have to then go and change your code, it's going to be quite painful. But if there's no updates for a while, that can be okay. If it's a stable dependency, and it does what it does, and it does it well, it's okay. But if not, it could also be a sign that that dependency is no longer actively supported. And in that case, you need to be aware of that, because that can be quite risky. If there's any issue, you'll probably have to fix it yourself. And we used a dependency at Deliveroo, which was used to generate some code in the Android manifest. And it worked. And it wasn't being developed for a few years, but it was okay, because it was doing exactly what it did, and it was working. Until we updated to Gradle free, and the task it was using was removed. And we had to go in and actually fix that. But for us, it was okay, because we knew it wasn't being worked on anymore. So it wasn't a surprise. But if you don't know that, then they come in as a big surprise. You might assume, yeah, they'll fix it, but nobody will fix it, because nobody's working on it anymore. And you'll have to actually spend a lot of time on fixing it, and probably forking the repository, maybe creating a pull request and hope that somebody will actually look at it. For us, we probably would have had the same problem if we wrote that code ourselves. The only thing is, it probably would have been a bit faster to fix it, because we knew the code. But that brings me to the next point. Check the code. And I don't mean going into every single class and every single line of code, but you do want to understand what is actually happening under the hood. What is that library actually doing? Like, how does it work? Is it actually well written? Is it performant? And does it actually do what you need? And also, it can be a great opportunity to learn. Maybe you'll find new coding patterns, a different way to perform an action, or just a different view on a problem. It can also save you from making mistakes, because you might make an assumption that a dependency works a certain way, but once you look at the code, you realize it doesn't. And also, a problem can seem very, very trivial. If you have an image loading library like Picasso or Glide, for example, you just call a single method, and it does everything for you. But there's a lot of things happening under the hood. So if you actually understand what's happening there, it helps you appreciate the problem more and all the hard work that it went in there. Another thing we want to check is code, is the tests. Like, are there any tests? If there's no tests, then any update can probably break your app, because how will they know that it will work? So make sure the dependency is well tested. Also, check samples, because those can actually help you to figure out how easy it is to actually integrate it. It might seem super easy because, you know, in the snippet, there's just one single method and it looks fine and easy. But once you actually see a full sample, it can seem a lot harder. And that will also help you figure out if that dependency is the right one for you. And lastly, check the dependencies. A dependency will sometimes depend on other dependencies. And sometimes you might not need those dependencies otherwise. So by using that dependency, you're going to use some other dependencies, which you don't want. Usually, you want to make sure that they depend on only the things that they actually need. If there's a library that depends on a bunch of different things, then your app size might grow. Retrofit does that really well. Like, it works with different JSON parsers like JSON and Moshi, but you don't have to include all of those in the dependency. They have a separate module which only works for JSON or Moshi, and you can then integrate that. Also, you want to make sure that these dependencies are actually of good quality too, because they can also break your app. Another thing to watch out there is version clashes. And that's especially true if you depend on something like the support library, which you generally want to keep up to date regularly. Now, if a dependency depends on a different version of your support library, you can force the version, but sometimes that might not be possible because that code would actually break. So that can be a problem. Now, I mentioned method count, and while it's not a big issue anymore, it can help you decide between a few different options. So let's take a look at 3 different image loading libraries: Picasso, Glide, and Fresco. They're all pretty popular, but Picasso, has about 1,000 methods, and Glide about 3,000, and Fresco has over 10,000 methods. So there's a huge difference. But they're also doing slightly different things. Picasso, for example, doesn't support animated GIFs, and Fresco has a huge effort on performance and memory consumption. So you want to check what you actually need, because sometimes you'll be fine with Picasso, and sometimes you're going to need Fresco. But knowing the method count can help you make a decision, because if you don't need any of the features of Fresco, you're probably fine with Picasso, and it's okay. Another thing I want to talk about is popularity. Now, popularity can be actually really, really important, because if you have an issue with a library, what are you going to do? Well, you're going to Google it. And if there's a lot of people out there that use that library, then somebody will probably have a solution for your problem. So it'll be very easy for you to fix it and find what the problem is. But if nobody else is using it, you'll have to figure out yourself what's actually happening. And that can cost a lot of time. Sometimes you might have to provide a bug report, or sometimes you might just have to fix it yourself. And for me, for a long time, I didn't want to use RxJava because of exactly that. Because RxJava has a huge learning curve. And I didn't want to integrate it, because if somebody joins the team, they don't know it, so they'll have to learn. And also, it's really hard to actually learn. So there needs to be a lot of information out there. And when I actually did start to use it, there were tons of blog posts, tons of talks out there, and it was really great to learn. But if everybody else would have done what I did, then nobody would have used RxJava, and there wouldn't have been any of those posts out there. So if you think a dependency is useful for you and works for you, then go ahead and use it. Just be aware that if there's an issue, it might take you a bit longer to fix it. But make sure to document it for others, because if somebody like me comes in later to use it, they can use it. Most importantly, though, it's always a team choice. You all have to work with that library. So if it doesn't work for you all, then it's not going to be great. And also, somebody might surprise you on your team and actually know a different option that works a lot better for you. Now, that sounds like a lot of work. You have to do a lot of research, but it shouldn't take you too long. If you just spend a few hours, you should generally have a good understanding of what's good and what's bad. You might have to spend some more time and actually integrate that library to see if it works for you, but all of that is time really well spent, because if you would write it yourself, it would take you a lot longer. So, which dependency should you use? And it's just whichever works for you. Your needs are the most important thing. A popular dependency is great, but if it doesn't work for your code base, it just won't work. So just go with what works for you. So we went over when and which dependency to use. And that's the last part. How do you actually integrate a dependency? And most dependencies will be available on JCenter or Maven Central. And that means you can use it with Gradle or Maven or your favorite build tool of choice. Now I'm going to assume you're using Gradle. And with that, it's very simple. You just have to add a single line of code in your Gradle file, and you can use that dependency. Now there's a few things you need to watch out for. And the first is the version number. Usually the version number uses semantic versioning, and that's like a major, a minor, and a patch version. The major version means there's going to be breaking changes. So if you update that library, you're probably going to have to update your code. A minor version is new functionality. So maybe you can remove a bunch of code that you need to write yourself and use a library, the version of the library instead. And the patch version is generally for bug fixes, so that should be relatively straightforward. Now, some dependencies will say you should use this as your version number, and that means the major version will be static, but the minor and the patch version will always use the latest version. Now, that sounds great, right? You're getting all the updates for free. You don't even have to do anything. But imagine a scenario. You're creating a release, and everything works fine, and then you actually test the app and something is broken. And you have no idea what's happening, because all of your dependencies are set up like this. And you're like, is it my code? Is it a dependencies? Which one is it? And you have no idea. And it'll take you a while to track down what the actual issue was. So if you provide static versions, that means the dependency will always be the same, no matter when you do that build. So you can debug an old APK, and it will still produce exactly the same code. So that's great. So it might seem a bit more complicated to use a static version, but it'll be better. You do want to make sure that you keep them up to date, though. And because you're getting bug fixes, or maybe there's a security fix, or maybe just new functionality. And I recommend to update after every release. So if you have a quite regular release cycle, then maybe like every 2 weeks. If you update after the release, that's the least risky time, because it'll take a while until the next release is happening. But also, it's still very regular, so you don't have to update 100 of dependencies at once, which is risky. Now, if you have a lot of dependencies, that can be quite tricky, and even just figuring out which dependency you should update can be hard. So there's this great plugin by Ben Maines called the Gradle Versions plugin, and all you have to do is run this single task, and it'll tell you which dependencies are up to date and which have an update, and which version you can update to. So that will help you to figure out which versions actually have an update, which dependencies have an update. Now, if there's a bunch of different dependencies that have an update, it can be quite a long task to actually update those. So how I usually go about that is that I start with patches, because those are simple. They should just be bug fixes and shouldn't have any requirements to actually change your code. So you just update those, and you want to still always check the changelog. Changelog will tell you everything about any new feature, any breaking changes, and which bug fixes were fixed. So sometimes a library might just sneak a new feature into a patch release, which isn't great, but it might happen. Sometimes they might deprecate some code that they're actually using, and you just want to make sure that you keep everything up to date. Sometimes, though, you don't actually want to update a library. Maybe it's targeting a new SDK, or maybe it's a major update, and it's actually quite a lot of work to do the update right now, and you want to do it at a different point, and that's okay. But if you don't check the changelog, you're just going to try and update it, and it'll break, and you're just going to revert it again. So just save the time and check the changelog first. If you do have a lot of big changes in a dependency, you probably want to do it as a separate change, because otherwise you might have a few bugs creeping in, and it will be hard to figure out which update actually caused it. Okay, so now you're using dependencies and it's all great, but your Gradle file gets quite out of hand. So how can you actually keep it a bit simple? Well, you might have a few dependencies like this, which is, for example, a support library does this, which actually has a few different modules. But you need to make sure that the version number is always the same for both of them. Now, obviously, you can update and just manually go and update both of those versions, but you can actually provide your version number as a separate string. And then you can just use it, and you only have to modify your version number once. Just make sure you need to use double quotes instead of single ones if you do that. Another thing you might want to do is grouping. Especially if you create different modules, you'll have to use your dependencies in different modules. And either you just copy the whole list, or maybe you create a new Gradle file that actually is being included in every module. But you can also just use the different groups of dependencies and integrate those. So this is how you can define a group. And then all you have to do is call that one line, and it'll integrate the whole group, not just like one dependency. There's a bunch of other things you can do to clean up your Gradle file, and especially if you use Kotlin to write your Gradle build scripts, then it'll be a lot easier for you to keep your Gradle file clean. So check those out. Right, so now we integrate it, but we're not actually using that dependency yet. We're just adding our lots of code to our app. So how do you use it? Well, you already know it, because you looked at the README, you looked at the samples, you already have a good understanding of how to actually integrate it. And it will always be a case-by-case thing for each dependency, but there's a few things you can watch out for. One is, often you want to add some abstraction. For example, there might be a dependency that you actually want to replace at some point, or maybe you want to disable it. And a good example for that is analytics. Analytics library is usually, you call one single method and you call it in a bunch of different places. Now, you can obviously just integrate it directly, call it everywhere, and it works. Until you want to disable it or replace it. Or maybe you want to test your code and you can't write unit tests because you're depending on that library there. So add some abstraction, create an interface, and just call that one method of your interface, and then have the real implementation of your dependency. And that means you can easily replace it, because you just have to modify that one file or one single place. And it'll be easier to test. But it doesn't always make sense. Sometimes a dependency will change the way you write an app. For example, RxJava or architecture components. You don't want to hide those away behind some abstraction, because you actually want to make use of those features. But I recommend to start small. It can be really tempting to just go in, rewrite your whole app, and use architecture components everywhere. But that's also risky. Maybe it doesn't work out. Maybe you actually start realizing, oh no, I didn't like that. I don't want to use it. one example for that is Lombok at Deliveroo. We used Lombok for our value classes, and it worked okay. We used it, we started integrating it, and then we switched to Kotlin. And data classes were a lot better for that use case. But also, once we updated to Gradle 3, and also once we tried to use KAPT, Lombok wasn't compatible with that, and we had to remove Lombok. If we would have gone in and replaced all our auto value classes, which is what we used before, it would have taken us ages. We'd probably still be there converting all those classes. But because we started small, it was less risky. Sometimes a dependency also takes some time to get used to. Sometimes you need to learn how it really works, and you need to improve. Maybe you started using Kotlin at some point, and the code you wrote in the beginning probably wasn't great. Mine, it wasn't. But if you learn something new, it will take time, and you'll improve. And then, if you figure out how everything works in one place, and then once you know how it works and get better, start using it everywhere, then you can already use that improved code, which is great. Okay, so now you're using your dependency, and now you want to give credit. And figuring out all your dependencies that you're using and which licenses they have can take a while. But luckily, there's this open source library from Google. And all you have to do is create a link somewhere in an app and start this activity, and it'll do all the work for you. So that's pretty good. OK, so how do you integrate a dependency? Well, however it's safest. Adding a dependency can be quite risky. But if you start small, add some abstraction, and use static versions, it can be safe. So being a lazy developer is quite a lot of work, actually. But it can also save you a lot of time, because you don't have to write a lot of code, and you can use somebody else's knowledge. But picking won't always be easy. But just remember, no choice is final. If something doesn't work for you, you can remove or replace it. It might not be super easy, but if you have some abstraction, it should be relatively easy. Also, your app will evolve, and what works one day might not work another day. It's just with any other code you write. At some point, you're going to refactor it, and you're going to change it. And the same might be true for your libraries. So yeah, building an app takes a really long time, but it can be a lot easier with dependencies. Thank you. If you have any questions, just